Okay, so today we're going to be talking about solving quadratic functions. So, first off, we're going to introduce the standard form of a quadratic equation. Okay, now the standard form is going to look like this: ax squared plus bx, very similar to what we've talked about before, but it's going to be equal to 0 this time. So, what you're going to do for quadratic equations is you're going to take this and you're going to solve it for x. And there's going to be a multitude of ways to actually solve this. Solve this for, whatever x is going to be. It's obviously not going to be 0. But you are going to start at 0 because there's some really unique stuff about this. Now, if you remember in your formula for working with height of an object that you throw up in the air, so it'd be negative 16t squared plus initial velocity t plus initial height. Okay, now when working with something like this, if you notice, h sub t and 0 are both the same. So, what does that lead me to believe? That here's the crazy thing, is that the solution for a quadratic equation has to be set up so that the height of the object is going to be 0. So that means something special when x equals 0. Okay, so let's actually take a look at it when we're solving a problem. Okay, alright, so let's take a look at something pretty simple. Let's go x squared plus 4x plus, well, let's go minus 4. No, let's go, yeah, let's just leave it at, let's see, plus 4, that's too high. I don't want that. Let's go x plus 2x minus 15. There we go. Alright, so here's our actual graph. Now, if you remember, the height was 0, so that means that the y is 0. Well, here's some interesting things. Okay, if I take a look at this, the graph is going to cross at 0. So this is h equals 0, or height equals 0, or y equals 0, and I get two of these. Okay, so what this is saying is that if I plug in, if you notice, these points are negative 5 comma 0 and 3 comma 0. So this is saying if I take negative 5 if I put negative 5 and plug it into here, I should get 0, because this is x and this is y, so that's the input. So let's try it out. So if I start plugging it in, so negative 5 squared plus 2 times negative 5, and then we minus 15. Okay, so we check it out. So this should be 25 minus 10 minus 15. Well, if you take a look at that, that is actually 0. So this is actually, negative 5 is a solution for this quadratic equation. So we're going to take more in-depth look at this and what these are. Let's try it out with the 3. Might as well. So we go 3, so we're going to go 3 squared plus 2 times 3 minus 15. Okay, well, 3 squared is 9, and 9 plus 6 is 15, but then we're going to minus 15. Well, guess what? That also equals 0. So because it's a number that I can plug into this equation and get out a true statement, that means it is a solution. So that necessarily means I don't really have to do all this work. All I have to do is graph it and look for these. Now, these go by many names. This will be solutions, or zeros, because they're related to the zeros, or roots. It doesn't matter how you use it or how you call it, just as long as you understand when you graph a parabola, okay, and you start looking at it, wherever it crosses the x-axis is an answer to that quadratic equation. Okay, so now we got two answers, and if you notice, the parabolic shape is going to cross it twice, and it could be negative, doesn't matter. Oops, maybe not so much negative. Let's change this to a positive. Voila. Okay, so as you can see, it could be going up, it could be going down. It still hits the axis twice. Now, what about these ones? Okay, this is x squared plus 4x plus 4. And I was messing around with it earlier, and I didn't want to talk about it right then. Okay, if you notice, it only hits the x-axis once. It comes down, hits it, and then goes back up. Okay, so that means that there's only one answer that would actually fit into there. Okay, so in other words, if I were to test it out, it would be -2 squared plus 4 times -2 plus 4. Okay, and so that would be 4 minus 8 plus 4. And if you notice, that will just turn into 0. And if I try any other number, it won't work. Okay, so my parabola can either be positive or it can be negative. Now obviously I need to change this to a -4. There we go. Okay, it could be positive, it could be going up, it could be going down, doesn't matter. It's still going to be the same process of just having one answer. Okay, now you're probably thinking to yourself, Mr. Devaney, not all parabolas cross the x-axis. You are correct. What about this? Does that mean that this is the answer? No. There is no real answer. So when you're looking at this one, there is no real answer for these type of problems. And we're going to discover a technique later to actually find those type of answers. But just give you a hint, it's not real. It's actually an imaginary answer. Okay? But we won't talk about that till Algebra 2, just because imaginary numbers are pretty crazy and stuff. But they're the solutions to these type of problems. So once again, you could have 2 solutions, you could have 1 solution, or you could have no real solutions. And obviously, when I say real, that means that these 2 are real, so this is real and this is real, or just this one is real, or none of them are real. Okay, now do not use the vertex, do not use the y-intercept, do not use anything else, but just the fact that how it crosses the x-axis, okay? Okay, so when you guys are taking a look at some of this stuff, we're going to actually derive some techniques too. So like for example, one of the beginning techniques is solving something like this: 3x squared minus 75 equals 0. This is a quadratic. Now one technique is when there is no x. This is pretty easy to solve. So you just add 75 to both sides. Okay, so that's pretty simple. So we got 3x squared equals 75. Okay, now what we're going to do is we're going to divide both sides by 3. Okay, that's pretty simple, Mr. Devaney. Okay. Alright, so you could just divide and voila, you are left with x squared equals 25. Alright, now to do the last step, you need to remember what is the opposite of squaring? It is square rooting. So you just square root both sides, and you would get x equal to this. Now you do need to account for both possible answers, because some of you guys are thinking, oh, it's just 5. No, it's also -5, because it could be positive or -5. Now if you wanted to verify this, go ahead and graph this and you'll see what I'm talking about. Okay, so this is 3x squared minus 75. Okay, and voila, I have a -5 and a +5, which are the same answers as what I got before. Now some of you guys are realizing, oh, Mr. Vanny, you didn't put y equals. Yeah, well, you can put y equals, or you can just leave it at b. It understands that it's y equals. Okay? Alright, now the cool thing is that you can graph it to get the answer, or you can solve it to get the answer. It's totally up to you. But remember, if it does not cross the x-axis, we do not have any real solutions, and you just have to say no real solutions. You don't have to go find the imaginary numbers that they are. Alright, so let's say that you wanted to find some answers, some real-world answers that actually apply some of this stuff, okay? Alright, so let's say that you're looking at a box or a sarcophagus or whatever you want to call it in the anthropology wing of the museum, where you're waiting for Indiana Jones. Okay, and you find that the width of the box is about 3 feet. Okay, and then you find the length is about twice that. Well, it's twice the height. Okay, and then you have the height here as well. Okay, so you have the height and you notice that the length is twice the height, but you only have the width as 3. But you do know that the volume of the box is about 420 cubic feet. So it'd be feet cubed. Okay, so how do I actually find the height and the length? So what you have to do is plug it into the formula. Now, obviously, the formula for volume is length times width times height. Okay, well, we know what the volume is. It's 420. All right, the length is 2h. The width is 3. And the height is h. So what we're going to get is 420 equals 6h squared. Now, if you notice, that's going to be a lot like what we just did. So what I'm going to do is divide both sides by 6, and I should get 70 equals h squared. Okay? All right? And the last step on this one is going to be square rooting. Okay, now obviously we're not going to do the plus or minus version of this one. We are just going to do the plus version because this is dealing with length. So this is about 8.36 feet is the height. Okay, now if that's 8.36, that means that this is going to be times by 2. This is going to be 16.73 feet right here for the actual length. So you actually found the dimensions by just noticing this stuff and working with a quadratic formula. Okay? All right, that's it for solving quadratic functions. You guys have a wonderful day. Bye.